Hello everyone, let's have a quick look at binary search algorithm in Python. So we are just going to go ahead and have a function here. We're going to call it binary search, right? So we have this function called binary search in Python, and we're going to have two parameters here. So we are taking in an array or a list, but I'll just try to call it an array. Okay, an array right here. And yes, we are having a target value, which is the value we are looking for in Python. And be in this array. In binary search, we want to have two variables here, which is the first and the last element. So in binary search, just like when you're going through a book and this book is arranged like this, a phone number books, like a contact book, and it's arranged alphabetically, and the person you're looking for now starts with the name Mattis, right? That's M, right? So when you open this book to the middle, and you see that the letter in the middle right there is just like, okay, let's say now you opening to the middle is not that accurate. You open to P. Now you know that yes, N is on the left side of this book and not on the right side, so you can just tear this book into two and throw away the right side and keep searching the left side. So you can just repeat that same process with the left side of the book, which you have. So if the book was 500 pages, you've reduced it to 250 pages. So when you repeat the same thing there and you keep discarding half of the book every time you search through this, every time you open this book, just to get to the lowest number possible to the page where you will find the contact you're looking for, which is multiple contact, right? So every time you discard this book, you are reducing the load you have to go through by half. So first 250, then 125, then just like that you are reducing it to like 62, just like that. So this is how binary search work. And the first part is just you have like your first page and your last page, which is just the last element here, and the last element will be the length of this list. That's the length of this array minus 1. That's because we use zero-based indexing, and the length of the array is going to give you back normal length starting from 1. So what we want to do is now, why this first element here, the first index here, is less than or equals to last. So we want to keep doing this. See, the first and the last index is the same thing, right? So we want to have the midpoint here, and the midpoint is just basically adding the two index together, dividing it by 2. So first plus last index. So now we divide it by 2. That's the fourth division, dividing it by 2, right? So when we divide this by 2, now we just want to have, okay, if the array, the midpoint now, if the value in the midpoint is equals to the target, so whenever this value is equals to the target, we want to return the target. We want to enter the index of this target itself. So we just want to return this index itself. So return midpoint. But otherwise now, if the value in this midpoint is less than target, just like the book analogy we used, the midpoint is less than the target, and that means now we move the starting index to the right of the middle point. If it's less than target, that means the value is on the right side of the list, right? So we move the starting index to the value after that target, after that midpoint. So elif if okay, array midpoint itself is less than target. So we want to just change the first element we are searching in this list to the midpoint plus 1. So that's index now. So we're basically discarding the left side, and otherwise, which means is greater than, right? So if this first condition is not met, the second one is not met, that means it's greater than. We want to discard the right side and move to the left side. So we are setting the last index to the midpoint minus 1. So we are going to keep repeating this until this condition here is false, right? So we can just go ahead and use this function right here. So list now, okay, I'll just say, okay, I have my array right here, and I say this my array now. What do I call this? Let's say this to 1 2 3 4 5. Oh, that's 5 6 7 8 9 10. And one thing about binary search is that the list you are searching for must be sorted. Just like the book analogy I used, it must be sorted. So we can just go ahead and say we want to print out binary search, and here we are passing in my array, right? My array, and we are looking for the target 7. So we're expecting the index of this 7 right here. So I'll just go ahead and run this. Okay, not getting any output. Okay, because there's a problem somewhere. Okay, coming. Okay, the problem right here is because these two function here is still under, these two statements here is still under the code itself. So I'll just go ahead and delete this back and show you why I put it earlier. So here now we're getting 2, that's 0 1 2, right? That's the right index of where we have in this 3. So I should run this again for 7. We are getting 6, right? That's because using 0-based indexing, the position here is going to be 6. So, but let's say I don't have 7 right here. If I don't have 7 right here and I run this now, I'm getting none. But if I want to get back the position that is meant to be, I can just go ahead and return first right here. So if I should go ahead and return first right here, you can see if 7 was existing, it's meant to be at the position 6, right? So that's how it's meant to be. And that will be all for today's tutorial. Thank you for watching. Don't forget to like and subscribe.